Namaskar, this is Rohit Shankamane and you are watching Scientists Are Academy Towards Scientific World. Now in this video lecture we are going to understand thin layer chromatography with respect to their definition, their different types, their different mechanisms, how it works in the lab and how we can perform in the lab, and at the end we are going to discuss how we can observe and how we can do the result analysis in the lab. So let's start our lecture. But before going to start our lecture, if you are new to my channel, subscribe to my channel and click on the bell icon for more updates. So TLC, that is thin layer chromatography, is one of the simplest, fastest, easiest and least expensive chromatography technique which is used in the qualitative and quantitative analysis to separate the organic compounds. And this technique is also used to test the purity of compounds, because in this technique we are going to use a glass plate which is layered with the silica gel. Now the silica gel, that is slide, we can borrow from the outside, that is ready-made TLC plates, or we can prepare in our lab also. The TLC is a form of liquid chromatography which consists of mobile phase, there is nothing but the solvent, and the stationary phase, which is nothing but the TLC plate with silica gel. And the analysis is performed in a flat surface under atmospheric pressure and the room temperature. Now, what is the principle of TLC? Now, see, the principle of TLC is totally depends on the adsorption or partition chromatography or combination of both. That is depending on adsorption. Now, let's see. We have one slide, and this slide is layered with the silica, thin layer of silica. And at the end, one end of the slide, around like 1 centimeter, we have kept one spot of a interested sample. Then this sample will run slowly or fastly, which is totally depends on the adsorbent or partition principle. That's what known as principle of TLC. And however, the sample is ran or and the solvent is ran, on the basis of that RF value is calculated. For example, say sample is here and the solvent has run here, so we have to calculate this length, and we have to keep this value in the formula, that is retention factor, that is RF is equal distance traveled by the component and the distance traveled by the solvent. This is nothing but the principle. Now stationary phase or coating materials used in the TLC. Now let's see that adsorbents are used silica gel, aluminium and cellulose powder. Mostly silica gel is used everywhere. Acidic or basic. Silica gel is acidic, alumina is basic and cellulose powder is a neutral. Components to be separated. Now with the help of silica gel, mostly acidic and neutral substances are separated, and alumina, basic and neutral components, and soluble compounds are separated by the cellulose powder. Preparation of TLC plate. Now how we can prepare the TLC plates? So first one, pouring technique. Now here the adsorbents are finally divided and homogeneous particle size is made into slurry and is poured on a plate and allowed to flow over it, so that is evenly covered. Now in the pouring technique, what we have to do, first we have to prepare a silica gel with the help of we have to take 1 gram of silica in 10 ml of distilled water or 100 ml of distilled water, and then we have to prepare one slurry, and that slurry we have to take, and with the help of that slurry we have to prepare a thin layer on the silica gel slide. Next technique is the dipping. Now here used for small plates of dipping the 2 plates at a time back to back in a slurry of adsorbent in a chloroform. Evenness of layer may not be good. Third one, spraying. The suspension of adsorbent or slurry is sprayed on a glass plate using a sprayer. So third one is very simple, and mostly the pouring technique is used everywhere. Next one, that is a spreading. It is the best technique where the TLC spreader is used. The glass plates of a specific dimension, this is the dimension of glass plates, are taken. The prepared slurry is poured inside the reservoir of TLC spreader. The thickness is adjusted by using the knob in the spreader. Mostly the normal thickness is used around 0.25, okay, which is for analytical purpose, and 2 mm for the preparative purpose. The plates are activated by keeping in an oven. Now once we prepare the thin layer on a slide, then we have to keep the slide in an oven for the drying purpose. Then we will get the dried silica gel layer on a slide. Then we can keep our sample and we can easily observe. Now what is mobile phase? Now mobile phase, it is a developing liquid phase which travels up the stationary phase carrying the samples with it. It totally depends on the nature of substance to be separated, that is polar or non-polar. Nature of stationary phase which is used, mode of chromatography. Solvents used should be high purity. Solvents mostly used are petroleum, ether, benzene, carbol, tetrachloride and the chloroform. Now let's see what is spotting, how we can do the spotting. Now spotting is done using capillary tube or micropipette. Now we have to remember this. Spotting of the sample on the TLC plate is carried out or is done by the capillary tube or micropipette. The spot should be kept at least 1 centimeter above the base or plate, and the spotting area should not be immersed in a mobile phase in developing chamber. Now whatever the sample we are taking, that sample we have to put or we have to spot on the silica gel plate above 1 centimeter from the base of the plate. The sample is applied on the narrow band and the width of the band must be narrow as possible. Now here we can see the sample, how we are the person is applying, and this plate also. Developing chamber. Now the developing chamber is used for the purpose of TLC plate run in a mobile phase. After the mobile phase is poured into the chamber, it is kept closed with the lid. Now whatever the solvent we are using, that solvent we have to pour in the beaker, and that beaker we have to keep our slide, that is silica gel slide, where we have spotted our sample, and we have to keep the sample in that chamber for an purpose. Now what are the detecting agents used? See, specifically after the development of chromatograph, the spots should be visualized. The detection colored spots can be done usually, but for detecting colorless spots, any one of the following techniques can be used. First one, non-specific method. Now here, where the numbers of spots can be detected but not exact nature of compound. Example, iodine chamber method. Now here, where brown or amber spots are observed when the paper is kept with a few iodine crystal at the bottom. Second technique, that is UV chamber for fluorescent compound, when the compounds are viewed under the UV chamber at 245 nanometer at or 365 nanometer, fluorescent compounds can be detected. And there are different methods, that is specific methods. Here the specific reagent will be sprayed on the TLC plate and then the compounds can be visualized. Mostly ferrichloride is used for phenolic compounds and tannins, ninhydrin acetylene for amino acids. So mostly in the BSc or MSc, ninhydrin is used because mostly amino acids got separated to the TLC. Dragonoff's reagent for alkalides, 3,5-dinitroarsenic acid for cardiac glycosides, 2,4-dinitrophenoxy hydrogen for aldehydes and ketones. Now how we can run TLC in lab? So first step is there are total 5 steps. First step is prepare the developing chamber. Second, prepare the TLC plate. Third, we have to spot the TLC. We have to spot the sample on TLC plate. Then we have to do the developing of the TLC plate and then visualize the spot. Now first, preparation of developing container. Now here we have to take a beaker with the watch glass on a top. Required quantity of solvents are taken into the beaker. Cover the beaker with watch glass and mix the solvents and keep them aside until the plate is prepared. Now here the preparation of the plate. Take the TLC plate and cut into the required length and width. Now mark a line about 1 cm from the bottom, and on the line space 2 dots at equal space we have to keep. Then spot of the TLC plate. Take the capillary tube, by the help of heat make it into two if it is new or if it is possible, so that the end of capillary tube will be thin. It helps to place a small amount of sample. Take the required solutions and spot them at the marker points. Develop the plate. Now put the TLC plate carefully into the beaker. The solution should not touch marked line. Close the beaker with the watch glass. Do not allow the solvent to run off the top of the plate. Now here this line we have to remember, that solution should not touch the marked line, otherwise solution will go in the solvent and we will not get the spots. Now visualization of the spots. Now after the some time we have to take off the TLC plate from the beaker very carefully and mark the solvent front line on the TLC plate and let it dry. Spray solution, whatever the solution we are going to use, for example ninhydrin solution for the amino acids, then observe the spot around it. with the pencil carefully. And then we can go for the calculation of RF value. Now we can do qualitative and the uh, qualitative analysis of RF value. Now here the formula is used that RF of component 1, that is dA divided by S, RF of component B, that dB divided by S. We can do like that, or we can use directly formula, that is RF is equals to distance traveled by the solvent divided by distance traveled by the solute. Now what are the advantages of TLC? So it is very simple process with a short development time, and it helps for the visualization of separate compounds spots easily. This method helps to identify the individual compounds, and it helps in the isolation of most of the compounds. The separation of process is faster, and the selectivity for compounds is higher. Even small differences in the chemistry is enough for the clear separation. It is very cheaper chromatographic technique. What are the applications? So it is used for the separation of classes of natural products, and is established as an analytical tool in the modern pharmacopoeias. Examples: acids, alcohols, glycols, alkaloids, amines, macromolecules like amino acids, proteins, peptides, antibiotics, etc. For checking the purity of samples as a purification process for identification of organic compounds. And this method is extensively used as a identification test, and is also used to detect the presence of foreign substances in the drugs. So this is all about the definition of TLC, types of TLC, how we can perform in the lab, that is the protocol for the TLC, how we can do the observation and the result analysis in the lab for the identification of compounds. So thanks a lot.